The objective of this lesson is to compare fractions by creating common denominators. Factors and multiples from previous lessons will be a helpful review as students learn to create common denominators. Let's begin by comparing 7/10 and 3/5. We can see that both fractions are greater than 1/2, but less than 1. However, it isn't immediately obvious which fraction is larger. Perhaps a model will help. Let's use a number line to model both fractions as we have in a previous lesson. Taking a number line partitioned into fifths, let's label each of the tick marks and mark 3/5. Now, using the same number line, we can create tenths by partitioning each fifth in half. This is because 5 is a factor of 10. Now we have 10 equal sections. As we label each tick mark, notice the equivalent fractions shown on the number line. 1/5 is equal to 2/10. 2/5 is equal to 4/10. 3/5 is equal to 6/10, and 4/5 is equal to 8/10. On the number line, we can see that 3/5 is the same as 6/10, so 7/10 is greater than 3/5. We could also create a common denominator without using the number line. For example, using the same fractions, we can look to see if the denominator of one fraction is a factor of the other denominator. In this case, we are looking to see if the 5 in 3/5 is a factor of the 10 in 7/10. Since 2 times 5 is 10, we know that 5 is a factor of 10. So let's create an equivalent fraction for 3/5 with a 10 as the denominator. To change the fifths to tenths, we need to multiply it by 2. Remember when we partitioned the fifths on the number line into 2 equal sections? That was actually multiplying 5 by 2. You will remember from a previous lesson that we also need to multiply the numerator by 2. So this shows that 3/5 is equal to 6/10, just as our number line showed. With common denominators, these fractions are easy to compare. 7/10 has more pieces than 6/10, so 7/10 is greater than 6/10, or 3/5. This strategy works well when one denominator is a factor of the other because we only have to find an equivalent fraction for one of the fractions in the set. But what about when one denominator is not a factor of the other? Let's compare this fraction set, 3/5 and 2/3. Immediately, we recognize that 3 is not a factor of 5. So another strategy that can be used to find common denominators is to multiply the denominators. To do this, we would multiply the numerator and denominator in 3/5 by 3, the denominator of 2/3. This creates the equivalent fraction 9/15. Next, multiply both the numerator and denominator of 2/3 by 5, the denominator of 3/5. This creates the equivalent fraction 10/15. Now that both denominators are the same, we can easily compare the fractions. 9/15 is less than 10/15, or 3/5 is less than 2/3. Let's compare two more fractions, 9/12 and 6/8. We could also multiply the denominators of these two fractions to find common denominators. To do this, multiply the numerator and denominator of 9/12 by 8, which would give us 72 over 96. Then multiply the numerator and denominator of 6/8 by 12, which would equal 72 over 96. You can see that this set of fractions is equivalent. However, in this case, multiplying the denominators can give us really large numbers. Another strategy for comparing fractions is to find a smaller common denominator. Let's use the same fractions, 9/12 and 6/8, and try this strategy. To do this, take the denominators of each fraction and make a list of its multiples. For 12, we would have 12, 24, 36, 48, 60, 72, 84, and 96. We could continue, but let's stop there. Now let's list the multiples of 8. They would be 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, and 96. Again, we could continue the list, but we will stop there. Notice all the common multiples: 24, 48, 72, and 96. We could use any of these multiples as common denominators. However, let's choose the smallest common multiple, 24. Using a smaller multiple will make computations easier. Let's begin with 9/12. We need to first find out what to multiply 12 by to get 24 as the denominator. 12 times 2 is 24, and we will need to multiply the numerator by the same number. This gives us the equivalent fraction of 18 over 24. Next, looking at 6/8, what do we need to multiply 8 by to get 24? 8 times 3 is 24. So let's multiply the numerator and denominator by 3. This gives us 18 over 24. This shows that this set of fractions is equivalent. Compare these calculations to when we previously just multiplied the denominators together. Notice that the result is the same, but using 24 as the denominator has the benefit of working with smaller numbers. However, remember that both strategies will result in a correct answer. The objective for this lesson was to compare fractions by creating common denominators. We met this objective by finding if one denominator was a factor of the other, multiplying the denominators, and using a smaller common denominator.